NASA treated the world to unforgettable views of the universe yesterday as it shared the first jaw-dropping images from the largest space observatory ever built. James Webb captured an unprecedented look at a stellar nursery, a dying star cloaked by dust, and a cosmic dance between a group of galaxies, along with hints of water vapor in the atmosphere of a remote exoplanet. However, the $10 billion (£7.4 billion) telescope's first images were not of newly observed regions of space. In fact, its famous predecessor Hubble had already captured Stephan's quintet, the Carina Nebula, galaxy cluster SMACS 0723, and the Southern Ring Nebula. But the two observatories look at the stars and galaxies in different ways, with Webb able to produce images that are 2 to 3 times sharper than Hubble's. It is also 100 times more powerful than astronomy's godfather of space telescopes and can peer much deeper into space. To show the difference in quality, Mail Online has taken the snaps released by the James Webb team yesterday and compared them to ones captured by Hubble. NASA likes to think of James Webb as a successor to Hubble rather than a replacement, as the two will work in tandem for a while. That's because they look at stars and galaxies in different ways. Hubble studies the universe predominantly at optical, or visible, wavelengths, which is the same type of light we detect with our eyes. Webb, on the other hand, is set up to specifically look in the infrared, which is invisible to our eyes but allows it to identify the glow from the most distant objects in the universe. It works in much the same way night vision goggles use thermal imaging technology to capture infrared light. Hubble studies the universe predominantly at ultraviolet and optical, or visible, wavelengths, which is the same type of light we detect with our eyes. Webb, on the other hand, is set up to specifically look in the infrared, which is invisible to our eyes but allows it to identify the glow from the most distant objects in the universe. It works in much the same way night vision goggles use thermal imaging technology to capture infrared light. Because the universe is expanding, just about all of the galaxies that we see from Earth are moving away from us. This means that to us, their light appears to have a longer wavelength, or a redshift. For very distant objects, this redshift is so large that they can only be observed in the infrared spectrum, which is where Webb comes in, while Hubble focuses on ultraviolet light. For this reason, the two will work in tandem for a while so that scientists can analyze the data provided by both to help advance our knowledge of the cosmos and how humans first came to be. Webb's first images were just the tip of the iceberg of what the observatory is expected to accomplish over the next 20 years, which could include capturing the very first stars to shine, detecting habitable planets in faraway galaxies, and peering back in time to within 100 to 200 million years of the Big Bang. What has astronomers most excited, however, apart from the prospect of witnessing the dawn of the universe more than 13.5 billion years ago, is the unknowns that Webb could discover, just like Hubble. The iconic Space Telescope, launched in 1990, helped to detect dark energy, as well as providing superlative images of the cosmos that included the Pillars of Creation, one of the most iconic images in astronomy. Among the most important scientific tools ever built, Hubble has made over 1.5 million observations of more than 43,500 celestial objects and helped publish some 18,000 scientific papers. It has contributed to a number of major discoveries in astronomy, including the observation that the observed expansion of the universe was accelerating. This then led to the conclusion that most of the cosmos is made up of mysterious dark energy, around 68%, according to NASA. Dark matter makes up about 27% and the rest, Everything on Earth, everything ever observed with all of our instruments, all normal matter adds up to less than 5% of the universe.